From the mobile studios of Way Happy, we are at the Student Union talking about 4-3 circular functions. And now it gets to the point where we are going to start translating our angles off of, or at least be bigger than quadrant one. So they will start to get really big, and you will notice that it gets a little crazy. What if it even gets bigger than 360? Or 2 pi, depending on how you look at it. So some things to know: in standard position, they will always have their initial side on the x-axis and then their terminal side pointing somewhere. And if you're going around counterclockwise, you notice that that's the positive angle measure. But if it's going counterclockwise, that's how we measure angles in the negative direction. And so funny thing is, an angle can look exactly the same but have a positive degrees or a negative degrees, but it could look exactly the same. And that leads us to our first thing about coterminal angles. Coterminal angles are angles with the same initial and terminal sides, but they have different angle measures. So that's kind of crazy. But the cool thing is the angle measures will be different by exactly 2 pi if we're talking radians, or by 360 if we're talking degrees. So here's an example of number one. I wanted you to graph one positive and one negative angle that looks exactly like negative 210. So what does negative 210 will look like first of all? So if I'm going to do negative 210, here's 0, here's negative 90, here's negative 180, here's negative 270. So negative 210 is, right here, and it looks like that. So that's what a negative 210 angle looks like. Great. But now let's get another negative angle that looks exactly like that. Well, the simple way is to add or subtract a 360. So I could subtract a 360, and so I would get 570, negative 570 degrees. So negative 570 degrees looks exactly like that. In fact, it would start here, and then it would go down around 360, and then it would go another 270, another 210 more, and get me right there. And that is negative 570. And those are coterminal. They look exactly the same on paper. They just differ by how many times you spun around. Now, what about going the other way? I could also measure this angle this way. So we could measure it, or we could just add 360. So negative 210 plus a 360. So they're different. So we're going to subtract them. That's 150. And so that's 150 degrees. So boom, there is one positive, 150, and there is one negative, negative 570, that look exactly the same as the one they gave me, negative 210. Now, radians can be done the same way. So they give me 13 pi over 4, which we could graph. That's like a little more over 3 pi. So if you think of what that graph looks like, there's, all the way around is 2 pi, then 3 pi, and it's a quarter more than that. So it's sitting right here. So there is 13 pi over 4. Now, you could just tell me what it is, or you could use the algebra or the numeral. You could just subtract or add 360, or in this case, 2 pi. So if I do 13 pi over 4 and I subtract a full revolution, that's going to look exactly the same, but give me a different measure. So let's see, what is that, 8/4? So that to me looks like 5 pi over 4. So there is one answer. So one answer could be 5 pi over 4. And now we got to do it again. We got to subtract it, but we got to get a negative answer this time. So I'm going to take that 5 pi over 4, and I'm going to subtract another 2 pi, or 8 pi over 4. That's negative 3 pi over 4. And there you have it, one positive and one negative. It looks exactly like 13 pi over 4. Super important thing to understand is that these angles look exactly the same on paper. So it's always legal to add or subtract a full revolution to get yourself maybe something that you can deal with, right? And in fact, now we'll get the reference angle and we'll actually be able to draw the sides of the triangle. There's also another set of things that we like to do to you, is just have you plot a point and then talk about the relationships of the sides. So there's two ways to do that. One way is to just draw the triangle that is created by the point that you plotted. And the other way is to memorize this little chart. This little chart is really helpful on what we call quadrantal angles, ones that are on the axes. But if it's not, then this chart isn't all that helpful. So let's talk about what I got here. So if you see, and I added C just so you would know what I'm talking about. Here's the first way, and usually I'm going to go ahead and graph because I don't want to memorize that chart. But here is 1, 2, 3, 4. So I'm going to go ahead and plot 3, 4. All that means is that you have this angle whose initial side is there and whose terminal side is there. So can you make a triangle? Well, heck yeah. You always pull the triangle straight down to the x-axis, always, always, always. X-axis, never y-axis. Here's your angle that you're talking about, the one included in the triangle. And now you just go ahead and give me all the sines, cosines, and tangents. Well, we know this was 3. We know this was 4. And through Pythagorean theorem, I know a squared, b squared, c squared. I know this is 5. So I can now give you everything for that. I can say that the sine of the angle is opposite over hypotenuse, 4/5. And the cosine of the angle is adjacent over hypotenuse. And tangent of the angle is opposite over adjacent. So boom, just by the drawing, I can get them all. Or you could have used this, right? Your favorite method, pick it and do it. It's nice. I'm just not a big fan of memorizing stuff. So for me, this is a little easier. But this also comes in handy, especially on letter C over there. All right, we know cosecant, secant, and cotangent are just the reciprocals. So if you flip those, you will get the other 3, and good job. So I'll do the same thing here. I'm going to graph 3, -4. So 1, 2, 3, 1, 2, 3, 4. So there's that point, right? So that means the angle looks like this. So then I need you to draw it back down to the x-axis. You have the 2 sides. And now you can go ahead and figure this a squared, b squared, c squared. Notice that that hypotenuse will always be positive because of Pythagorean theorem. And now you can go ahead and you can do this too. You can be like, all right, sine is opposite over hypotenuse. So the sine of the angle is -4/5. Cosine is 3/5. And tangent is -4/3. And you are golden with your angles. All right, last one. You'll see where the big trouble comes. 0, 5. So 0, 5, I guess I should put that a little lower. 1, 2, 3, 4, 5, boom. So the angle looks like this. How the heck am I supposed to draw that triangle? And there's a good example of where you can see where this little hints come in. Now I'll show you with the hand trick how you can do it too, because all 0 whatevers are going to be the same. But for now, I'm just going to show you the chart. So I'll be, all right, this is your x and this is your y. And I know that r is 0 squared plus 25. So it's really just also 5. So sine of the angle is the y value over the r. So that's 5 over 5, which is 1. I have the cosine of the angle is the x over the r, or 0 over 5, which is 0. And tangent of the angle is the y over the x, or in our case 5 over 0, which is undefined. And there you have it. Flip all of those and you will see that you will have cosecant, secant, and cotangent. You might notice something weird about secant, right? It's going to be undefined, and cotangent is actually going to be 0. All right, let me ask you a question and I'll be right back. All right, excellent work. And let's just make sure you got it one more time. So a nice thing to know, but I'm going to show you something in a little bit that's different. But if a nice thing to know that if you want to know it is that sine is the y value over r, cosine is the x value over r, and tangent is the y value over x. All right, so if you can remember that, then you know the flips for the other 3. So now I go ahead and if I do sine of 180, not a big deal. I'm sorry, sine of pi. I know that that angle's here. So boom, it looks like that, right? So you could pick any point you want on there. So let's pick this point right here, the point -1, 0. So that point, you could pick -2, 0. You could pick -10, 0. I don't care. They're all going to be the same. And what will happen is they ask me for the sine of that value. So that is the y value over the r value. So for me, that is going to be the y value is 0 over the r value. If you square them, add them together, square root, you're going to get 1. So the answer is 0. In fact, the sine of 180 degrees will always be 0, no matter what point you pick. That's why it doesn't matter. All right, what about cosine of -360? If I go to -360, that's around this way all the way to here. So there's your graph. Pick any point you want on there. I'll pick, just to show you, I will pick the point 9, 0. Right? Now they want cosine. So cosine is the x value over the r value. Now my r value is a squared plus b squared equals c squared. So 9 squared plus 0 squared is 81, and then square rooted is 9. So my cosine value is going to be the x over the r, or 9 over 9, which is 1. In fact, it'll always be 1 for cosine of 0 degrees or 360 or negative 360. So that's just a nice thing to know, and that's where these little things come in handy. All right, what about 3 pi over 2? Well, I know where 3 pi over 2 is. That's 1.5 pi's. That's right here. So there's my angle. I will pick any point I want here. Let's pick the 0.05. Now cosecant is the opposite of sine, so that's going to be r over y. Well, if you do the math, r is 5. Oops, somebody catch it, that was negative 5. So the r value is negative. So r value is 5, but the y value is negative 5. And guess what? Answer is negative 1. Done. That's what cosecant is. It's sine, but it's flipped. And be careful you brought it along. And now, last but not least, secant of 11 pi over 2. Well, that I don't like, because I don't know where 11 pi over 2 is. So the good news is I can add 2 pi's and not change what it looks like at all. So I will add 2 pi's, which would be 4 pi over 2. Well, you know what? I'm actually going to add it a couple of times. I'm actually going to add 12 pi over 2, right? Because that is legal. Why? That is 3 revolutions around. So I just added 3 revolutions. So what will that give me? That will give me the secant of pi over 2. That looks exactly the same. That's the cool thing about coterminal angles. So I'm like, all right, well, what's pi over 2? That's straight up. Let's call that now like a normal person, the 0.01, but you can pick 0, whatever. Secant is the opposite of cosine. So if cosine is r over x, then this is x over, if cosine is x over r, then this is r over x. And so the r value would be 1, the x value would be 0. Oh no, it's undefined. So it's an undefined value, and we are done. That is that piece. Now let me ask you one question like that, and I'll be right back. All right, great work. Now we move to the part where we could do any angle, no matter where it is, if we use reference angles. Remember reference angles? Here's where they become important. So if you notice, we are going to be able to do anything that's not one of those x-axis, y-axis angles. You're gonna draw the angle, and then you're going to find the reference angle. And then you're going to use the hand trick, or if you memorize the ratios, you're going to use that trick to tell me what cosecant is. And sometimes you might have to use, a coterminal angle to get the drawing right, but that's all it's based down to. So super duper fun stuff to see how your brain is working. And then this is just the stuff that we're going to like, because it's kind of fun. This would be a good Kahoot game, I can tell you that right now. So I'm going to go ahead and do cosecant of negative 60 degrees. So first thing I want to do is I want to draw negative 60 degrees. And I should also tell you about all students take calculus. Let me take a minute to tell you that. Here is a very important tool. It is all students take calculus, right? And what that stands for is really which trig functions are positive. See, that looks like a big plus sign. In which quadrant? If you are in quadrant 1, all the trig functions are positive. If you are in quadrant 2, then sine is positive. Everybody else is negative. Well, sine and its sister. Tangent is positive in quadrant 3, and in quadrant 4, cosine is positive, everybody else is negative. Now, why is that helpful? Because now I don't have to care about the sign of the sides of the triangle. Remember up above in the earlier examples, I had to worry about, if this was -4 and then I did sine. If I knew this, I wouldn't have had to worry about that. So in fact, I use this every single time. So like right now, I'm going to draw a triangle, and that triangle is negative 60 degrees. Or first, let me draw the angle. Here's negative 60 degrees. Now I know the sides of the triangle. If this is 60 degrees, that's the reference angle is 60 degrees. I know this triangle. I know the sides of the triangle, right? I could fill them in, or I will use my hand trick. In fact, I will always use my hand trick. So here's my hand trick. Oh gosh, that's really bad. But this is the folded down finger. And so remember, this is your sine value and this is your cosine value. And so how many fingers do you have over, root number of fingers over 2? Now, cosecant is the same thing as sine. And so all I have to do is flip sine. So if sine would be root 3 over 2, then cosecant is 2 over root 3, and I'm finished. Right? Now, the only thing I do have to worry about is a positive or negative, because notice I didn't worry about the signs of the triangle, positive or negative stuff. So that's where the all students take calculus comes in. We were in quadrant 4 with our drawing. So that means cosine is the only positive one. Well, cosecant is sine. So therefore it should be negative, because cosine was the only positive. This guy is the only negative, and bam, done. Right? Now you could have got that by drawing the triangle, right? If you knew your sides of a right triangle or whatever, if you know the hypotenuse is 1 and the short side's a half and the long sides read 3 over 2, that's awesome. And then you probably would put, positive and negative, and then you would do cosecant. You would end up getting the exact same thing, right? Because cosine is adjacent over hypotenuse, or sine is opposite over hypotenuse. Well, we would do hypotenuse over opposite, and that's how we would get that answer. So either way, if you want to draw the triangles or if you don't want to draw the triangles and use your hand, beautiful, beautiful method. Now look, I'll do cosine of 7 pi over 4. First, I need to figure out where 7 pi over 4 is. Well, I think I know where that is. That is right here again. That's kind of boring, but in this quadrant. So this is 7 pi over 4, which means the reference angle is pi over 4, because that's 8 over 4 is 2 pi. So that's how I knew where it was so quickly. I could label the sides of the triangle, or I'm good to go now. I can use my hand. I can be like, boom, boom, boom. This is the one that's folded down. Boom, boom. They want cosine, so that's root 2 over 2. And now I just got to decide, is it positive or negative? Well, cosine is positive in quadrant 4. We are in quadrant 4, so boom, root 2 over 2 is our final answer. Isn't that kind of fancy? How fast I could do cosine 7 pi over 4? Now, yeah, it takes a little practice, but you'll get there. Look at negative 5 pi over 6. I'm already thinking where that is. That's almost negative 1 pi, which means it's chilling right about here in the negative direction. It was measured this way. Remember to draw your triangle. Tell me your reference angle. That's why your reference angle is so important. Well, that would be 6 pi over 6. So this reference angle is pi over 6. What finger is that? Well, this is pi over 2, pi over 3, pi over 4, pi over 6, and then 0. So pi over 6 is folded down right here. Now remember, sine is this guy right here, so root 1 over 2, or what most people would call 1/2. So the answer is 1/2. But what quadrant is it in? It's in quadrant 3. All students take tangent's the only positive, so my answer better be negative. So boom, negative 1/2. Piece of cake. Again, you could have drawn the triangle, probably take a little longer, but beautiful. Done, ready to go. Last but not least, tangent of 120. So here I go with 120. Where the heck is 120? This is a 180, I know, and this is 90. So 120 is like right here. So in that quadrant, sine is the only positive one. So I know tangent is negative. So I already know my answer is negative. But what does this angle look like? Well, the reference angle would be 60 degrees. So a 60-degree angle. If I need tangent, so here's my fingers, boom, 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 boom. So this is 90, this is 60. So this is the folded down one. This is sine, this is cosine, and tangent is, if you want to remember this for future, tangent is sine over cosine, so it is root 3 over root 1. That's all tangent is, sine over cosine. The 2's would cancel this case, so there's your answer, root 3, and we said negative, so boom, there is tangent of 120. That's a lot, and that we need to practice, and that's fun. You need to know all students take calculus, and you need to know your hand, and you don't need a unit circle. You don't have to memorize all that junk on the unit circle. You got a hand that does it all. Now you have to know reference angles, and you have to know all students take calculus. That you do have to know if you're going to use your hand, but if you can do that, your hand's everywhere, and life is golden. So we can talk about that. All right, what else can I give you? Find cosine and cotangent if I know sine. All right, that's nothing too fancy. I would probably draw a picture. So if somebody tells me that sine is positive 1/2, all students take calculus, it's positive here and here. So I know that you're either in quadrant 1 or quadrant 2. Wait, tangent's negative. So I know you're in quadrant 2, you're not in quadrant 1, because it said right here tangent was negative. So I know that there is a triangle that's living in quadrant 2 because of the information they gave me, whose sine, so that's what the triangle looks like, whose sine opposite over hypotenuse is 1/2. And so because I know that, I can do a squared, b squared, c squared. So 4 minus 1 is root 3. And I can tell you all the trigs. I can tell you that sine is 1/2. I can tell you that cosine is root 3 over 2. And I can tell you that tangent is 1 over root 3. Oh, they wanted cotangent. So cotangent is root 3 over 1. Now, what should I tell you? All students, only sine was positive. So cosine's negative and cotangent's negative. And there's your two answers. That's it. Have a great day. Stay happy.